Good morning and very welcome to this new video. Uh, my dear students, in this video I am going to show you how can we derive Logit function from in event occurring or an event not occurring. And similarly, we can also use the Logit function to go back to the original function yi. So let me start with the introduction and usually in the logistic regression model or in the Logit models, the dependent variable has a binary or dichotomous categories. That is, it has two categories. Let us suppose y is equal to 1 if the respondent decides to buy a car, and 0 if he or she doesn't buy a car. So there are only two categories. If y is equal to 1, that is when the respondent or the subject decides to purchase a car, then the probability that she or he is going to buy a car is given as follows, and this probability is 1 divided by 1 plus e raised to the power minus zi, where zi is equal to beta naught plus beta 1 xi if it is a one variable regression, and if it has more than one explanatory variables, then zi will be equal to beta naught plus beta 1 x1i plus beta 2 x2i, and so on. Similarly, the probability of an event that the subject doesn't decide to buy a car is given by 1 minus pi, and that is equal to 1 divided by 1 plus e raised to the power zi. So, we must keep this in mind that the probability of the event occurring is given by 1 divided by 1 plus e raised to the power minus zi, and the probability of the event not occurring, that is 1 minus p, is given by 1 divided by 1 plus e raised to the power zi, and in both cases zi is equal to beta naught plus beta 1 xi, and so on. Now in this slide you can see that y is equal to e raised to the power zi whole divided by 1 plus e raised to the power zi, and this is also equal to y is equal to 1 divided by 1 plus e raised to the power minus zi that we mentioned in earlier slide. Uh, we can multiply y uh, by 1 plus e raised to the power beta naught plus beta 1 x 1. So we have like this, and that will be equal to e raised to the power beta naught plus beta 1 x1. Then we can open this and we multiply this by y, so we have y here, and we can also multiply this by y, so we have y here, and that will be equal to the right hand side. That is equal to y, and we can take this term to the left hand side, so we have e raised to the power zi or e raised to the power beta naught plus beta 1 x1 minus e raised to the power beta naught plus beta 1 x1 times y. So we have y is equal to 1 minus y times e raised to the power beta naught plus beta 1 x1, and finally we can write y divided by 1 minus y, and that is equal to e raised to the power beta naught plus beta 1 x1. And if you take natural log on both sides of equation number 2, then we have natural log y divided by 1 minus y, and that is equal to zi, and zi is equal to beta naught plus beta 1 x1i. And if you take the natural log of the exponential function, then that becomes the linear function. So that is equal to beta naught plus beta 1 x1. In case of one explanative, this is in case of one explanative variable. If we have more than one explanative variable, then in that case we have natural log of y divided by 1 minus I is equal to zi, and that is equal to beta naught plus beta 1 x1i plus beta 2 x2i up to beta k xki. This is in case of multiple explanatory variables. The Logit function that we just discussed can translate back to the original y as follows. Writing equation number 3 in exponential form, we can write y divided by 1 minus y e raised to the power zi, that is e raised to the power beta naught plus beta 1 x1i, and we can write y is equal to 1 minus y, we can take this 1 minus y to this side, and we will multiply this with e raised to the power beta naught plus beta 1 x1I, and then finally we can write y is equal to e raised to the power zi, that is beta naught plus beta 1 x1 minus e raised to the power beta naught plus beta 1 x1 times y, and we can write this y is y plus e raised to the power beta naught plus beta 1 x1 times y, and that is equal to the right hand side, that is e raised to the power beta naught beta 1 xy, and we can take y common, that is 1 plus e raised to the power beta naught plus beta 1 x1I times y is equal to e raised to the power beta 1 plus beta naught plus beta 1 x1I, and we can write y is equal to e raised to the power zi divided by 1 plus e raised to the power zi. So this is how we can write the Logit function and the original y function back from the Logit functions. So finally we can write like this: 1 minus pi, that is when y is equal to 0, is given by 1 divided by 1 plus e raised to the power 1 raised to the power zi is the probability of the event not occurring, and pi is the probability of the event occurring, and that is equal to 1 divided by 1 plus e raised to the power minus zi r, that is also equal to e raised to the power zi divided by 1 plus e raised to the power zi. So thank you very much for watching this video. I hope this was quite informative and useful. If you haven't yet subscribed to the channel, kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get timely and regular notification about my other videos that I'll upload for you. Thanks for watching. Kindly subscribe various videos of this channel in various WhatsApp groups.